All right, so 4.8 is applications of triangles. So I've just kind of created a little note page that should be attached in a file. These first couple of pictures, I just want to kind of get an idea of bearings. It's something that, unless you've done a lot of ships or navigational stuff, you may not have seen much of. But when they do surveying, navigation, like boating, hiking, things like that, we use a compass. They use a kind of a different measurement than in other things. So a bearing measures the acute angle that a path or a line of sight makes with a fixed north-south line. So I always draw my north-south line when I'm looking at bearings. And then there's kind of two ways that they could give it to you. The first way is like down here where it says south 35 degrees east. And what that's doing is that's telling you where you start and where you finish. So if I go from the south and I go 35 degrees to the east, so that's what this picture is from the south to the east. And so this would be my path line. Okay, so on this example, they say north to west. So north is our starting, west is our ending. So we're going north 80 degrees west. So from the north, instead of east, you're going west. So you're going this direction, 80 degrees to the west. So that would be your path of navigation or your path of whatever. And the final one is north 45 degrees east. So that's from the north and to the east, with that being our path. Now, sometimes you'll also see what's called true bearings. True bearings come always from the north. So if they don't give you directional bearings, so if they don't have the directional, then you could just go this way. And with those, they tend to go clockwise. So this might be just 45 degrees true, like that. And that would be that. Now, for this one, to get a true bearing, you'd have to go from the north and then wrap all the way back around to here. So that would be 90 plus another 90, so 180, plus another 90, so 270, plus the 10. So this would be 280 degrees true north. This one is 90 plus the difference. So this is 35 down here. We know altogether that's 90. So I do a little quick math of 90 minus 35, which would give me 55. And so then I'd add that to the 90 up above. So 90 plus 55 would give me 145 degrees true. So if you ever see a T with it, it's going straight from the north clockwise. If it has the two directionals, so this is more of what we'll see in your homework, is the two directional with the north and west or south and east and so forth. All right. Now we're also just going to do some sample problems. Most of this is using your right triangle trigonometry, like from 4.3. But we're not necessarily finding all the pieces like we did in 4.3. A safety regulation states that a maximum angle of elevation of a rescue ladder is 72 degrees. A fire department's longest ladder is 110 feet. What is the maximum safe rescue height? So if you imagine your little building here, here's the ground, right? Here's my ladder coming up. Now the ladder height, the ladder is here, so that would be 110 degrees feet. 110 degrees feet. I want to know the height, so there's my x. I always put my x where my height is. Now 72 degrees is the angle of elevation. So remember, elevation is up, so that's the angle from the horizontal up. So that's down here in this corner. Now I just need to realize which SOHCAHTOA. So if you think of your SOHCAHTOA, I have opposite and hypotenuse, so that's sine. So I set up sine of 72 is opposite over 110, the hypotenuse. If my x that I'm looking for is on the top, then I just multiply over. So I multiply by the 110. And we talked about this before in 4.3, is that if for ACT, they'll leave it like this. So 110 sine of 72, this is what we call the setup. That is a great answer. If you want an actual decimal answer, then you would go to your calculator And you can go any kind of calculator that has that sine value. Make sure it's in degrees though, if you're getting crazy answers. Sometimes that happens. So I'm going to go 110 times sine of 72. And I get 104.6. And that would be in feet. Okay. Let's look at a second example. Next, we have a swimming pool that's 20 meters long and 12 meters wide. So I'm going to kind of go ahead and draw my rectangular swimming pool. 20 meters long, 12 meters wide. The bottom of the pool is slanted so that we think of the water at the depth is 1.3 meters at the shallow and then 4 meters at the deep end. Okay. So if you think of it maybe like that, with a depth here of 1.3 and a deep, that's our other dimension. Find the angle of depression in degrees of the bottom of the pool. So I'm going to do just the deep part of it. Now the 1.3 is coming from some top surface. So if I think of the top surface of the water, this is the 1.3 up here, and this is 4. So if I actually want to know how much it's changing, so what's the difference in that height as it goes 20 feet long? Its height, let's see, its change would be what, 2.7, going that way, meters. Find the angle of depression. Now, angle of depression has to come from the horizontal down. So they're actually wanting this angle. Okay, that angle is parallel. Let's see if we get parallel lines cut by a transversal. That's going to match this angle down here. Okay, parallel lines cut by that transversal. So we can find that, but let's see, opposite over adjacent. That's O, that's A. That means this is tangent of what I'm looking for. Is 2.7 over our 20 meters long. And then I'm going to use, that's your setup. Oops, sorry, let me show you the setup. As my setup. And then on here, I'm going to go inverse tangent. So I'm going to use the second, so I have the tangent with the -1 of 2.7, not times, divided by 20. And that gives me 7.68 as my angle. Okay. All right. Example 3 on the back. Ship leaves port at noon and heads due west at 20 knots. So if I think of my starting, it's going to go due west, so it's going to go straight west at 20 knots or 20 nautical miles per hour. So that's noon and 20 knots. At 2 p.m., the ship changes course. So how long? 2 hours at 20 knots. So that's 20 times 2, or 40 along that direction. Now the ship is going to change course. So now he's going to go north 54 degrees west. So I'm going to draw a little bitty axis right here. Here's my north-south line and my east-west line. I'm going north 54 to the west. So he's going this way. Okay, with this angle in here being the 54. Find the ship's bearing and distance from the point at 3 p.m. So he's gone another 1 hour at 20 miles. So he's going to go 20 at that. And then I want to connect it back to where I started. Find the ship's bearing and distance from the port of departure at 3 p.m. All right, so what we want to do is we're going to make a little right. We can make a right triangle. All right, so you want, let's see.
Okay, we got the 40, we've got our 20. We can find the angle. We want that angle, okay? And we know the 54 here. So if I go, let's find that coordinates. Think of that right triangle, sorry. I should have done a different color. So if I make a right triangle up here with the 20 and the 54, I can find
The total distance traveled
up, so we can make a bigger triangle. So we want to find that height up. So let's see, that would be, you got the hypotenuse, that would be my adjacent. So cosine of 54 would give me x over 20, and that x would be this side or this side. They're both the same. Okay, so I'm going to multiply the 20 over. And that's going to give me 11.7, let's round to 6 for that. Now, if we think of that big triangle, okay, I know this is the 11.76. This is part 40, but part is going to be this other piece of that triangle. So I'm going to find it also by doing sine of 54 would give me y over 20. So 20 times sine of 54 would give me the y. So that would be what I'm going to put right there. So I'm going to take 20 times sine of 54. That's going to give me 16.18. So this is 16.18 plus the 40. So together, I have 56.18 and 11.76. So I could do Pythagorean's theorem if I'd like. So I'm going to come over here. Let's just move it up. Let's go Pythagorean's down here. So a squared plus b squared equals c squared. Okay. Okay, we get that, and then we're going to square root that. All right, so that gives me a C of 57 point, let's go 4. And that was miles. And that was the first question. Find the ship's bearings and the distance. So this finds the distance. Distance from port. To get the ship's bearing, we need the angle. So we're going to want the angle in here. So let's use inverse tangent. Tangent of our theta would be our 56.18 over our 11.76. And then we can just do inverse tangent. Oops. Inverse tangent, 56.18 divided by our 11.76. And we get about a 78 degree angle. All right.